approximating distributions going from a binomial to a normal distribution. Question 1, part A. So we have a binomial distribution and we check to see if the conditions for the approximation are met. We have a large value of n and p is close to 0.5, so that's good. And we work out the mean and variance for the binomial distribution. We do the continuity correction, less than or equal to 70. So in green are values that we do want, all the way down to 0, we want those. We don't want 71 or 72 and so on. The boundary between what we want and what we don't want is 70.5. So now we have a problem that's in the normal distribution. Mean, variance, and py less than. The equals is not going to do anything there, you can put it in if you like. And the 70.5 was that boundary there. This is for the continuity correction. We do a sketch. We're shading to the left of 70.5. The mean was 72. We're looking for this region here. Put the values into your calculator. Normal cumulative distribution function on the calculator. Be careful with the variance. You have to square root this to get the standard deviation. And here's the probability. This is an estimate to this probability. Part B, same distribution, px equals 80. So this time we have a single value that we want. So on either side are values that we do not want. So there's a lower boundary here, 79.5, and an upper boundary here, 80.5. So that's where these two values come from. So on our sketch, 72 again in the middle, that's the mean. 79.5, 80.5, it's this region that we're looking for. Calculator, lower limit, upper limit, standard deviation, and this is the probability. Again, this is an estimate to this. Part C, probability x greater than 75. So we don't want the 75, but we want 76, 77, and so on. So the continuity correction. So these are the ones that we want. In between what we want and what we don't want is 75.5. So we're working out this probability. So 75.5 here. We're shading to the right. We're looking for this region. Values in the calculator. And here's the probability. Again, this is an estimate to this. Part D, we need to work out the percentage error in the calculation that we did in Part A. This is what we did in Part A, and this is the probability calculated using the normal approximation. So now we're going to calculate the probability using the exact binomial. So we're not going to do any of this. We're going to use the calculator's built-in binomial distribution function, and we're going to calculate this probability using the exact binomial distribution. So we need the binomial cumulative distribution variable, and x is 70, this value here, n is 150, p is 0.48, and this is the probability, and this is the exact binomial probability. So we have the exact binomial probability and the approximation to it. So we need a formula, which is this. This will give us the percentage error. So it's just the difference between them divided by the exact one, and then you times by 100 to get a percentage. So putting the numbers in, and the percentage error is about 0.111%, so a very, very low percentage error. And such a low percentage error can be attributed to a large value of n and a probability really close to 0.5. Example 2. In this one we're just looking at the continuity correction because we have some algebra in this. Okay, so n is 90, p is unknown. It doesn't matter what the value of p is for my example. Px more than or equal to q. Okay, so let's start with q. And one value greater than q would be q plus 1. And we know we're going to go all the way up to 90. We have n equals 90, 90 trials. So these are the probabilities that we want. So now we need to look at what we don't want. So that's one value less than q, q minus 1, q minus 2, q minus 3, all the way down to 0. We don't want these values. The boundary in between them is what we're looking for. So to go from this value to what's in between, we just subtract a half. Okay, so we get q minus 0.5. So the continuity correction will be the probability that y is greater than, and here's the value in the middle, q minus 0.5, and then we continue working with this. For further practice, try these questions.